Alright, tonight's video is looking at the steps of the scientific method, and you'll see that we're actually going to be looking at an online textbook that Mrs. Sandler and I put together a couple years ago that we're going to use throughout this section. So you'll see on my screen, this is our Earth Science topic page. You guys know that there's a new topic now, the scientific method topic, and I'm going to go into that. Alright, you guys are watching the video that's right here. Obviously it's not on my screen because I'm making it right now. But the scientific method online link is should still be on your topic. So if I click on this, you'll see that it takes me to the online textbook that Mrs. Sandler and I wrote about the scientific method. And today we're going to be going over this first step, steps of the scientific method. All right, so you don't need to load this on your computer because you're going to see it right here. But this is where I'm getting this information from. So today in our video we're going to take a look at the steps of the scientific method. Make these notes a little bit bigger. I'm going to zoom in a little bit more on that so that way you guys can see it a little more easily. Go 15. Excellent. Alright, so there are 8 steps to the scientific method, and we'll talk about each one of those briefly. But first off, what is the scientific method? Alright, so the scientific method is a problem-solving process scientists use to learn about the world around us. Alright, so the key is that we're using this to solve problems, right? It's a methodical problem-solving process that we're going to use to learn about the world around us. And it's got 8 steps. We're going to go through each in order. So the first step is we need to identify the problem. Alright, it is tough to solve a problem if you don't know what it is. So the first step is to identify the problem. And in this we're going to state the problem we want to learn about in the form of a question. Alright, so it's important that we have a good problem, because if we don't state our problem clearly, we won't know what we're going to be investigating. So we need a clear problem. Alright, it needs to be clearly written, have it clearly stated what you're looking for. So our next step is to collect information. Alright, when we collect information, we are going to be looking to see what others have learned about our problem, right? Maybe it turns out that other people have done this research before. Maybe there's not as much that we need to do. So we want to see what others have learned, all right? And we want to know if there's anything we could add on to that information. After we've collected info, we're going to develop a hypothesis. We'll talk a lot more about this next week, about what goes into making a hypothesis, but this is our educated guess at the answer to the problem. Alright, so this is our best guess as to what the answer is. It's based on information we learned. Alright, so it's based on the info that we learned in this step. Right, so this is not just our, well, I think it's this. Right, we've gotten some information and we're seeing what we know. Doesn't necessarily have to be information that we've researched online or in a book. It could be based on your past experiences. Right, maybe you've done a whole bunch of stuff like this and you have an idea of what will happen. Right, our next step is to test our hypothesis. Right, testing our hypothesis. This is when we conduct our experiments. We conduct an experiment or study. All right, sometimes we'll talk about how to do an experiment. All right, and so we may set up an experiment, or we may study something that exists in nature to learn about it. Right, and we need to. The key with testing our hypothesis is we need an organized plan. All right. We'll need to have a procedure, right? And we call this plan our procedure. this explains what we're going to do in the lab. So we need this organized plan, we need this procedure, otherwise we're just kind of going all over the place and not really necessarily learning about what we want to learn about. So having an organized plan helps us make sure that we get the information we want. Next, we're going to analyze the data. Oh dear. There we go, analyze the data. Alright, so when we do this, now we've done our experiment, we have our results. We're going to look at the results from the experiment, right? And we're going to kind of see what this tells us. We want to organize data so that we can compare it easily. So we're going to organize data to compare. Once we've kind of looked at our data and we have an idea of what's going on, we want to draw our conclusions. Alright, and so we're going to use our data and either accept or reject our hypothesis. And we're either going to say, yes, my hypothesis was correct, or no, my hypothesis wasn't correct, or the other option is we can partially accept it. Maybe it was sort of right, but not quite. So we could partially accept our hypothesis. All right, so drawing conclusions this is the answer to the problem. So this is kind of, ultimately, this is the answer to the problem from step 1. This is the answer to our problem. All right, and we have to use that data that we got in step 5 and in 4. We have to use that data to accept or reject our hypothesis. We can't just say, well, I think it should be this. We have to use what we've learned. Our next step is to repeat our work. All right? Maybe the first time you did an experiment, maybe it just something didn't go right. Maybe you forgot to feed the fish and you were trying to see if one type of fish food worked better. All right? Maybe you forgot to feed the fish a couple days. That could have messed up your work. Maybe it was something you didn't even know would have happened. Maybe some of those fish were just weaker than the other fish. Maybe they were sick when you got them and you had no idea. So we always repeat our work. So we do the experiment again. All right? And what this does is this kind of gives us, it kind of backs up our data. If we see the same thing multiple times, right, we can be pretty sure our results are accurate. Right? If we get stuff all over the place, maybe that means our experiment isn't working. Maybe we need to go back to this step and design a better experiment to show what we really need to show. So by repeating the work, this kind of lets us know if our data are valid. All right? Data is actually a plural word, so it's data are. So it lets us know if our data are valid, right, and correct. And then our last step is to publish our work. All right? Scientists always share their work with other scientists. That's a key part of science, is publicly sharing the information that you have learned about. All right? This is going to be useful to other scientists when they are trying to collect info in step 2. Right? If we don't share what we've learned, other scientists won't be able to learn from our results. So we share our results. All right? And this allows other scientists to learn from our work. All right? And it lets them build on our work as well. All right, so those are the 8 steps to the scientific method. Identify the problem, collect info, form a hypothesis, test our hypothesis, analyze the data, draw conclusions, repeat work, and publish your work. All right, we will go over this in class next week after the break, and make sure that you write a summary at the bottom. All right, 2 to 3 sentences in your own words, and I will see you guys tomorrow.